Hello, we're given a demand and supply function as shown on the screen. The first question is find equilibrium price and quantity. Of course, in equilibrium, we have quantity demanded equal to quantity supplied. So I'm just going to set these two functions equal to each other. So we have 300,000 plus 40,000 PT, that's the price of a taxi ride, minus 60,000 PM, price of metro, equal to 480,000 plus 40,000 PM. Of course, we're looking for equilibrium price in the market for metros, so we have to find or put PM separate and alone on the left hand side. So if I move them over, I have PM here, and then I'm going to put all the other variables on the other side. So you have 300,000 minus 480,000 plus 40,000 PT. All right, simplifying here, and we get PM equals, so we have minus 180,000, of course, divided by 100,000, plus 40,000 divided by 100,000 times PT. All right, simplify one more time just to make it look nice. And we have minus 1.8 plus 0.4 PT. However, in the problem, we're given that PT right now equals 12 AED dirhams. And so if we plug that in, we have our equilibrium price equal to minus 1.8 plus 0.4 times 12 minus 1.8 plus 0.4, that is of course equal to 4.8, which means that the equilibrium price is equal to 3, which was in fact the price of a metro ride in Dubai. And then we want to find the quantity of metro rides. Again, we can plug that into either the demand function or the supply function. I'm going to do the supply since that has fewer terms. Right, plug in the value for equilibrium price there. And we have our equilibrium quantity as well, 600,000. So in the market for metro rides, the price is 3, and the number of rides is 600,000. Okay, in the next slide, I'm going to just find some derivatives and then find the price elasticity of demand. Okay, so I've rewritten the demand function here, and I'm asked to find the derivative quantity demanded with respect to the price of the own good, PM here. So that's of course 0 plus 0 minus 60,000. Right, so the partial derivative here is minus 60,000. Take the derivative of quantity demanded with respect to the price of T, taxis, and we have plus 40,000. So this is a negative number and this is a positive number. Basically what we're saying here is that if the price of metros increase, the quantity demanded for metros will go down. That is, we have a downward sloping demand curve. And we're also saying that when the price of taxes increase, quantity demanded for metros increase, so taxes and metros are substitutes. All right, so for 3, I asked to find the price elasticity of demand. All right, so price elasticity of demand. We know that price elasticity of demand is the percentage change in quantity demanded divided by percentage change in price. All right, so I'm going to rewrite the equation here. So what we're going to have is partial of quantity demanded with respect to price times the price divided by quantity demanded in equilibrium, because we're looking for price elasticity demand at the original equilibrium here. So we already know what these things are, so I'm going to plug in the partial, which is minus 60,000. We just found that. We know the price was equal to 3, and the equilibrium quantity was 600,000, which gives us a price elasticity demand equal to negative 0.3. That is, if you increase the price by 1%, quantity demanded will go down by 0.3%. All right, that's it. Thank you.